variables. The first thing we want to do is we want to eliminate the same variable twice. I'm going to let you pick it. You tell me what variable you'd like to get rid of. What variable would you like to get rid of? You want to get rid of z? Doesn't matter. We can get rid of the z's. Okay? So to get rid of the z's, for me to start this, I'm going to use the first and third. Okay, I'm going to use the first equation and third equation. So I've got x plus 2y plus 3z is equal to 5. 3x minus 2y minus z is equal to 3. Now we said we wanted to get rid of z. I'm going to multiply this equation by 3. Because remember, all I'm trying to do is get rid of z right now. I'm going to rewrite the first equation, x plus 2y plus 3z is equal to 5. This gives me 9x minus 6y minus 3z is equal to 9. Everybody good there? Can add them together. 10x minus 4y is going to be equal to 14. So now I have an equation in two variables. Got them in x and y. Got 10x minus 4y is equal to 14. Good?
Why are you multiplying just the second one by 3? Like, I didn't understand.
Oh, because I just want to get rid of the z, and there's a 3 up here already. Okay? All right. So let me put this over here. I have 10x minus 4y is equal to 14. Now, I want to get rid of z again, because I want to get another equation in just two variables, x and y. So I use the first and the third in order to do that. So now I'm going to use the second and third. Use the second and third. I've got 2x minus y plus 2z is equal to 8. I've got 3x minus 2y minus z is equal to 3. Everybody okay? Good. Now I need to get rid of z again. So we multiply the second equation by 2. And multiply by 2. First equation, 2x minus y plus 2z is equal to 8. This gives me 6x minus 4y minus 2z is equal to 6. Step back. Everybody okay? All I did there was multiply everything through by 2. Going to add them together. Gives me 8x minus 5y is equal to 14. And I've eliminated z again, so I have another equation that's just in x and y. Everybody good? Multiplication good? Addition good? I take this equation, 8x minus 5y is going to be equal to 14. So now I have two equations in two variables, both of them in x and y. Good shape? You can eliminate either the x's or the y's, totally up to you. I'm going to go and get rid of the y. I'm going to multiply the top equation by 5. I'm going to multiply the second equation by negative 4, because remember now we want to come up with the same coefficient with different signs. So I've got 50x minus 20y is equal to 70. This gives me negative 32x plus 20y is going to be equal to negative 56. Okay, if my multiplication is correct. Good? All right. Positive 50, negative 32 gives me 18x is going to be equal to 70 minus 56 gives me what? 14. So now I've got a fraction in this problem. I've got x equals 14 eighteenths. 14 eighteenths is going to reduce to what? 7 ninths. So x is 7/9. There's a reason I chose this problem. If you remember, in the other problems we had done last class, we ended up with some fractions, and we said, well, we don't like to plug fractions back in here, so what we're going to have to do is we're going to have to go in and resolve that particular system for the other variable. That's what we're going to do. So I've got 10x minus 4y is equal to 14. I've got 8x minus 5y is equal to 14. Now, instead of eliminating the y's to solve for x, I'm going to get rid of the x's and solve for y. I've got a positive 10 and a positive 8. I want to come up with the same coefficient but with different signs. What should I multiply by? What should I multiply by? No, you can do negative 8 and 10, absolutely. Is there something I could use to make the numbers a little smaller? But that'll work. Negative 5 and 4, that'll give me 40 instead of 80 for a coefficient. Either way works. Either way works. Okay. Here, I'm going to multiply this equation by 4. I'm going to multiply this equation by negative 5. 4 times 10x is 40x. 4 times negative 4y is negative 16y. And 4 times 14 is going to give me 56. Down here, this gives me negative 40x plus 25y is going to be equal to negative 70, right? 5 times 14, yeah, 70. Now we've eliminated the x's and we can find out what y is. Negative 16 and positive 25 gives me 9y is going to be equal to negative 14. We good? We good there? Okay. So y is going to be equal to a negative 14/9. Negative 14/9. Good? Math good? Multiplication good? You all right? Things good? All right. Now, we have to find out what z is. Now here you are going to have to mess with fractions a little bit. I'm going to use this value for x and this value for y. Now the good news is they both have the same denominator, so we're okay. I'm going to plug them in this equation here because you'll notice that the coefficient of z is negative 1. It's just a 1. So I've got 3x, which would be 3 times 7/9, minus 2y, which is 2 times negative 14/9, minus z is equal to 3. Okay. So here we plug them in. Now I'm going to multiply. 3 times 7/9 gives me 21/9. Now could I reduce that first? Yeah, but I don't want to. I want to keep the same denominators. Negative 2 times negative 14/9 gives me a positive 28/9 minus z is going to be equal to 3. 21 plus 28 is going to give me 49/9. So I've got 49/9 minus z is going to be equal to 3. So I end up with negative z is going to be equal to, first of all, the whole number 3 is how many ninths? 27/9, right? 27/9. Okay. So I've got 27/9, which is going to be positive. Bring this over, I get a negative 49/9. Negative 49, positive 27 gives me what? Negative 22, right? Negative 22/9. I've got negative 22/9. Got to divide both sides by negative 1. So z is going to be equal to a positive 22/9. Okay, positive 22/9.